So again, good morning to all. So in this lecture, I will discuss the concept of bubble sort. In the past, we have seen that the concept of selection sort as well as insertion sort. So this program is very important from array point of view. So it will learn you couple of things, and my task is to sort the element in an increasing order. Okay. So in the past, we have discussed selection sort and insertion sort, and this time we are going to discuss the concept of bubble sort. Okay. So let me explain to you. Let's say A is an array and having 1, 2, 3, 4, 5, 6, 7, 8 elements. So what is the purpose? I will take a pointer 0, and every time I am going to increase the pointer. And what I will do? I will compare the value of pointer and pointer plus 1. So current time, what is the value of pointer? The value of pointer is 0. So I will compare pointer and pointer plus 1. It means 0 and 1. So I will compare 10 and 20. If the right side value is lesser and the left side value is greater, then I will perform swapping. Okay. So in this case, 10 is smaller, 20 is greater. So I will not swap. So content will remain as it is. Then what I will do, now I will increase the value, or we can say I will increase the pointer. So last time the value of pointer was 0 according to programming, and according to algorithm it was 1. Okay. So I will increase the pointer, and now I will compare 20 and 1. Are you following this? Pointer I will increase like this. So I will compare 20 and 1, and the moment I know that 20 is greater and 1 is smaller, so what I will do? I will swap the values. So it becomes like this one. Okay. Now I will again increase the pointer, and I will compare the value of 20 and value of 9. So what will happen? I will again swap the values. So let me swap. Following this one, then I will again increment the pointer, and I will compare the value of 20 and value of 60. So 20 is smaller and 60 is greater. So I am not going to perform swapping. So the content will remain as it is. Are you following this one? The content will remain as it is. Now what I will do? I will compare. I will increment the pointer, and I will compare value of 60 and 45. So what is happening? 60 is greater, 45 is smaller. Then I am going to perform swapping. So you have to keep one thing in mind. Increment the pointer is independent of swapping. I will swap or I will not swap will depend on the content. But every time the pointer will be increased. Okay. So pointer will come here. And I will compare 60 with 30. So what is happened? 30 is smaller, 60 is greater, so I will perform swapping like this. Then in last I will compare content of 60 and 26. So I will get like this one, this one, this one, and this one, and 26 and 60. So what is the purpose of these? If you will look closely, one pass has been over, and the largest value inside this array, please pay attention, largest value inside this array has got its correct position. Are you following this one? The largest value inside this array was 60. Okay, and 60 has been kept at the right side. So what I will do? I will repeat the statement. I will repeat the complete statement starting from 0, but not till the last moment. Till the last moment minus 1, because initially I have 1, 2, 3, 4, 5, 8 elements. So initially I have 8 elements. In order to compare 8 elements, I need 7 pass, or we can say 7 comparisons, because in order to compare 2 elements, what is going to happen? In order to compare 2 elements, I will get 1 element shorted. Okay. So one comparison will short 2 elements. Are you following this one? So I have 8 elements. So I need 7 comparisons. But what will happen? This time In the next pass, what will happen? I will take input as this one because this is already sorted and it has got the correct place. So I will again repeat the process. So let me repeat once for you. 1, 9, 20, then 45, then 30, then 26. Why 26? Because 60 is already sorted, so it will be written like this one, but I will not apply the loop. Are you following this one? The content of array will remain as it is. I am not going to apply the loop. Let me turn the camera so that you can visualize properly, like this one. Okay, fine. And let me turn off the light also. So what is going to happen? I think it is visible to you. Yeah, fine. It is visible to you. So what is going to happen? I am again going to repeat the process. How I can repeat the process? The value of ptr becomes 0, and I will compare these two. The moment I have got the value left side value smaller, right side value greater, so I will perform swapping. Okay, then I will keep all value as it is. Are you following this? Then what will happen? I will compare 10 with 9. Again 10 is greater, so I am going to perform swapping. So first time pointer was there, second time pointer was there, and all the values will remain as it is. So you have to write this value, but this value will remain as it is. Third time I will compare this one. So what is going to happen? It becomes 10. So content will remain as it is because 20 is lesser and 45 is greater. So the content will remain as it is. Fourth time I will compare 45 with 30. Then what is going to happen? I will perform swapping. So it becomes like this, 26 and 60. The next time I will compare 45 with 26. So it becomes 1, 9, 10, 20, 30, then 26, then 45, then 60. So please look at the comparisons. 1, 2, 3, 4, 5, 6. Last time I have 7 comparisons like this. And this time I have 6 comparisons. Why? One comparison has been reduced because I am not going to compare this one and this one. Why? Because it is already sorted. Or we can say that 60 had got its correct place, and after second pass 45 also has got its correct place. So what will happen? Initially the problem size was n. In order to compare n element, I need n minus 1 comparisons. Next time I have to sort n minus 1 comparisons. So what will happen? I need n minus 2 comparisons because I have to sort n minus 1 number. In order to sort n minus 1 number, I need n minus 2 comparisons, and here the value of n is 8. That's why first time we have 7 comparisons, then it becomes 7, that becomes 6 comparisons. Okay, are you following this? That is quite easy. Now let me again repeat the process for you. Let me again repeat the process. Okay, so next time what will happen? So I will take as input 1, 9, 10, 20, 30, 26, 45 and 60. But while repeating the process, you have to keep 2 things in mind. You have to keep 2 things in mind. That 2 elements were already sorted. If 2 elements are already sorted, what is going to happen? We just need to sort 6 elements. Okay, we just need to sort 6 elements. So I will again put the pointer at 0 and I will compare 1 and 9. So the content will remain as it is. Are you following this? Content will remain as it is. Then I will compare 9 with 10. There is no need to perform swapping. So content will remain as it is in this comparison. So it becomes 1, 9, 10, 20, 30, 26, 45 and 60. Next time I will compare 20 and 30. So what will happen? Again compare, then content will remain as it is. There is no need to change the content. Okay. Next time what is happen? I will compare 30 with 60. So we need to perform swapping. So it becomes 1, 9, 10, 20 as it is. That is 26 and 30. Then 45 and 60. Then we doesn't need to compare these three because these two elements has got its correct position. Now third one also got correct position. So if you like look at the compare, so I have just 4 comparisons. So in third pass, first one I have 7 comparisons, then I have 6 comparisons, then I have 5 comparisons, then I have I have 5 comparisons. Are you following this one? 5 and then I have 4 like this. So every time comparison will be less, and at the last what will happen? You will get just 2 elements and you have to sort the numbers. So after the like n minus 1 pass, n minus 2 in fact, n minus 2 pass, what will happen? You will get odd element sorted. Okay. So in the next video, probably in this video, we can design the algorithms. So let me design the algorithm. Okay, for you. So let me design the algorithm for bubble sort. So I will write bubble sort. A is an array having n number of elements. So I am writing the algorithm. So index will start from 1. Are you following this? Index will start from 1. So for I equals 1 to n minus 1. Why n minus 1? Because if I have n elements, so how many passes required? Just n minus 1 pass is required. Okay. And the value of ptr equals 0. And just apply loop for j starting from 1 to n minus 1. Are you following this one? Why n minus 1? Because let's say the value of n is 10. So in the first one, the 9th value and 10th value will be compared. Are you following this? 9th value and 10th value will be compared. The moment you will compare last two values, this one will be automatically sorted. Okay. So if you have 3 elements, 2 comparisons are required. If you have 9 elements, 8 comparisons are required. If you have n elements, so n minus 1 comparisons are required. Are you following this? So that is the step number 2, step number 3, and let me start step number 4. In step number 4, you will compare if a of ptr, it means the value on the left side is greater a of ptr plus 1. And the value at the right side. So what you will do? You will perform swapping. So you will write 1, 2, 3, 4, 5 like this. Swap a of ptr and a of ptr plus 1. Are you following this one? So you have to swap the value. Every time if you are performing swapping or not, it is not dependent on pointer. So every time you have to increment the pointer. ptr equals ptr plus 1. Okay. So that is the complete algorithm for bubble sort. So you can run this algorithm and you can convert this inside the program. So probably it is your homework to convert this inside the program. So from like array point of view, we have covered 3 sorting algorithms. First one is selection sort, second one is bubble sort, and third one is insertion sort. So idea behind insertion sort is we will pick 2 elements and we will pick like sort 2 like element. Then we will pick third one and we will identify the correct position of this third element among these 2 elements. So what will happen? These 3 elements will become sorted. Then we will pick fourth one and we will try to identify the correct position of this fourth element among these 3. So fourth element will be sorted like this. Okay. In selection sort, the idea behind this one is traverse the complete array and we'll try to find out the smallest element and we'll swap with 0. Then we will repeat the statement but starting from 1 because at the leftmost side element was got is the correct position. Are you following this one? Then we will start the procedure from 1 to end of the array and we will try the location of the smallest element and swap it 2. But in bubble sort, what we are going to do? We are making pass and in every pass we are going to make the largest element at the right side. Okay. So you can just go through all the sorting algorithms. So you will be clear with the sorting. Okay. So thanks to all for watching this video.